3-part storage perspective. You can go do some hands-on, say, hey, here is how I do Go provision. We didn't have time to highlight it, but also we have our management console for the HP 3-part storage. You can go configure your entire DR infrastructure in 15 minutes. It's not weeks or months. You can just take your entire DR infrastructure, configure within 15 minutes. More as complicated as not just a one-to-one replication, even if it is a 4-to-1 replication, or even if it is a 3 data center replication, you get all these views from a single console. You just drag and drop saying, here is my links to this particular data center, and you can just configure it that way. Very simple. So you could get some hands-on on using the interface and be comfortable on how do you provision, how do you manage your infrastructure. And also, of course, visit the HP website. You'll have more information. We have documentation on the same topics that we talked about, implementing 3-part, implementing VMware with 3-part. We have a white paper on it. And also we have the entire, it's a product brochure, I would say, which will give you, here are all the different technologies that we have within our portfolio, and here's what each one of them does within your environment, for your environment. And you can go take a look and say, okay, this makes sense, or I need to have this additional piece of software to be able to do this. So it gives you a good view of what it means with all the different pieces of software that we have. I think that's pretty much one presentation. We'll have 10 more minutes open for questions.
So you absolutely the EMC to part Cornell?
Yeah. How we actually did it?
Yeah. What you had how you
So is your question specifically about how we physically did the migration?
No, the system we had to begin with, and what to say.
Start with the 6 words that you migrated off of.
What model?
So what were we running? What were we doing? So we had email. We had one for databases, one for our clinical systems, one for backups. I honestly forget. It's been quite a while since I figured the two before. But we migrated basically all of the workloads that we were using. We had a small implementation of Exchange at the time. We had a 30,000 seat implementation of Cornell system. We migrated that. We also migrated our VMware environment. We migrated Cache, which is our electronic medical record database. And everything else, all the other small systems that we had on there, we migrated everything that we were running off of EMC onto the 3-part. No. So we looked at DMX. DMX was one of the things that we considered for about 30 seconds. So we looked at the requirements for DMX as far as space, power, cooling, all those things. And the footprint of the data center alone was just a showstopper for us. We needed 2 frames, basically, just to get in the door with the DMX. I'm sorry, it was 3 frames. Just to get our foot in the door. And we didn't have the power to run it, and it was ridiculously expensive for us. So right away, it fell out of the running. And we weren't really prepared to go back to EMC for the CX4 at the time, because it was basically the CX3 just sort of nothing really that new. But we wanted something that was sort of in between, and 3-part really kind of fit. We wanted to graduate from having the CX500, the CX4 into something a little larger, and fit in there very nicely.
I have a question about the autonomic storage tiering you spoke about.
Sure.
So, and how quickly that moves. A lot of this is all about VMware, this presentation today, but, for instance, in VMware View, you have your golden master that gets hit heavily, right? Read on a boot storm or whatever, it gets hit heavily. So, I guess the question is, let's say that happens just sort of once a day, right? Maybe at 9 o'clock, there's this huge boot storm, there's this big push on those blocks, and then the rest of the day it kind of falls off. So the next day at 9 o'clock, it's going to happen again, right? So are those blocks going to be up in tier 0, or will they have fallen off? And is there a way to peg anything to tier 0 for your autonomic tiering?
Yeah, absolutely. Good question. The lowest interval today from a storage perspective is 1 hour, right? That's the lowest that you can move the data across. Right? Going back to the VDI environment, um, we have a global customer, or it's a global financial customer, who runs 4,000 VDI on a single 3-part T400, right? So going back to the boot-storms, if you look at the boot-storms, it's primarily read ahead, right? So most of the information, what you could read ahead, is already in our cache. So with the ability to have the data in the cache, and with the massive IOPS that you get from the drives, we never encounter the boot storm issue at all. And same is true with login storms and everything else. And to answer the next part, definitely there is a way to say, hey, within the same array, right, you could say, this particular volume, I don't want it to be part of adaptive optimization, right? So that what it means is you're pegging the data that's on that LAN to that particular tier. So it's very much configurable within the array. You could say this volumes are part of the adaptive optimization, this is not, this is part of this RAID configuration, this is not, and all data movements, right, whether it's from a RAID 5 to a RAID 10 if you want to convert it, they're all done online. There is no disruption to your host application at all. So it's all configurable within the array.
With the respect to your decision to go with 3-part, did you look at any? Did you look at the left-hand solution, and was there a comparison why you chose 3-part over left-hand?
Well, at the time, left-hand was still left-hand, so it wasn't sort of in the portfolio, and 3-part was 3-part, so it wasn't in the HP portfolio, so it wasn't something that we looked at. But as far as left-hand is concerned, we didn't. iSCSI is not something that we're prepared. We're not, even today, we're not really prepared to do it either. We have a much better fiber channel infrastructure, and personally, I'm not willing to abdicate control out to our networking guys. No offense to any networking guys. But fiber channels is different. I mean, it's a whole different world than Ethernet is. So it wasn't something that we considered.
Go ahead.
You mentioned that you were able to have more density for your ones. With my understanding for fiber channel data store, it really the main factor is the single IO queue and a lot of the locking behavior. I don't really understand how 3-part actually makes the data store more dense for fiber channel.
Can you get? I didn't get the question. Go ahead.
So you're saying how you can have more dense data stores for your VMs?
Yeah.
But my understanding is it's still limited by the fact for your NFS that you have a single disk IO queue going to the data store. You also have the study locking behavior. I don't see how that's more of a fiber channel issue rather than the storage array.
The question is on the 3-part storage. How do we say that we can consolidate a larger number of VMs? I'm just trying to paraphrase your question. How we consolidate a larger number of VMs when we know there is certain limitations around if it's fiber channel, it's this, if it's NFS, it's this. So what is it that makes 3-part be able to consolidate more number of VMs? Right. See, one of the things is, let's take the concept of having other parameters constant, meaning you're in a fiber channel network, right? When you go across NFS, it's a whole different discussion that we can have, and why fiber channel is better than NFS, right? Let's not get to that discussion. But assuming, let's put all the other parameters constant to say, here is my host, and here is my fiber channel infrastructure, and here is my storage, right? So if you were going to deploy 10 VMs for LAN, the reason why you would do that is because of a couple of reasons. Study reservation is one of them, right? And the I/O bottleneck would then move to your disk because, as we all know, VMware really requires performance on the disk. It's all random I/O. You can't just solve it by cache, right? If you're just going to solve it by cache, you need to have gigabytes, terabytes of cache in your environment, right? Because they're all random I/O. So what you need is massive IOPS from your disk. And if you go look at our SPC1 IOPS, our SPC1 IOPS or T800 is 225,000 IOPS, all from this, not from cache. So we have a massive IOPS that we can drive to the disk, right? So a combination of both, which is having a higher IOPS on the disk itself, we can double the number of VMs. The disk will never be a bottleneck. We can add more number of VMs, and on a parallel basis, we can still store those VMs from an IOPS perspective.
What's the
Maximum?
data store you've seen how many VMs?
Oh, we have seen customers all the way from 20 to 40 VMs for a while. And as I said, one of our financial customers, they have 4,000 VMs deployed on a single T400. And of course, you have room to become T800, right? One half of the system, we have 4,000 VMs deployed in a VPN. Any other questions? Okay, thanks.
As far as setting up, allocating the lump to the VM, what's more best practice? Is it 500 gigs or is it terabytes? Is it 2 terabytes or what?
From a 3-part perspective, there is no unique thing to say, hey, it needs to be 500 gig or it needs to be 2 terabytes. From what I understand is with the newer, especially with these 4.1 implementation, with the VAI implementation, you're less prone to have any SCSI reservation issues, right? So in that case, it's better to have a larger LAN, and if you are running anything prior to 4.1, it's preferable to have a smaller LAN. Essentially means that you will have a smaller number of VMs on a per LAN basis.
We have been growing our LANs, over time. We had this discussion between our VM administrator. I don't see any benefit by keeping the LANs small. We start off with 500 gigs. Some of them are a terabyte now. I don't see any benefit of having them small.
Okay, thank you guys.